everyone, I'm Jai and today we are going to see different types of delay in the computer network. So let's start. So to understand the packet loss and delay, let's see one example. You can see that there are two devices, which is device A and B, are connected to router. Let's name this router as R1 and the next router, which is the R1 is connected, that is R2. Now A wants to send 4 packets, B wants to send 3 packets. Okay, now the link that is connected to A and R1, it is X, the link that is connected to B and R1, it is Y, and link that is connected to R1 and R2 is Z. Right, now let's consider first case. In the first case, the speed of X and Y, the data rate that link X and Y can carry is 1 Mbps, and the data rate that Z can carry is 10 Mbps. So suppose if A is sending any data to, let's say, any other computer over the internet, so the link that is connected to A and R1 is of 1 Mbps, and the link that is connected to R1 and R2 is of 10 Mbps. So in that case, the router R1 is receiving data at very low rate and router R1 is forwarding data to R2 at very high rate. So in the first case, there will be no problem. R1 can easily receive the packet, R1 can easily process that packet, and it can forward the packet to the next router. Now let's consider the second situation. In the second situation, the X and Y is of 10 Mbps and Z is of 10 Mbps. So suppose B is sending some data to another computer over the internet. So B can send data to R1 at 10 Mbps. Why? Because the link Y can transfer 10 Mbps data. So B will transfer data at 10 Mbps to R1, and R1 can also forward that data to R2 at 10 Mbps. In the second case, R1 is not going to face any issue. R1 will easily receive data from B because the receiving rate is 10 Mbps, and R1 will easily analyze that packet and it will forward that packet to next router, and it can transfer data at very high rate. Now let's consider the last situation. In the last situation, the router is receiving data at 10 Mbps. You can see that in the last case, the X and Y is of 10 Mbps. So R1 will receive data at 10 Mbps at very high rate. But because of the Z is of only 1 Mbps, the R1 is not able to forward that data, that packets at that much high rate. Are you getting it? R1, because of the X and Y is of high speed and Z is of low speed, R1 will receive data at very high rate. It will receive all the packets at very high rate, but it will not able to forward that packet at that much fast rate. So what will happen, that all the packets will be chalked up and it will be queued at the R1. So you can see that all the packets are queued up, and because of this queue is happening at the R1, it will create delay. Okay, so you can see that in the buffer all the packets are stored, so that is why it is known as delay. And because these all packets are queued up, all the packets have to wait until the packet just before them to get transmitted. So for example, until this packet gets transmitted, this packet has to wait. Until this packet gets transmitted, this packet has to wait. All the packet has to wait until the packet just before them is transmitted. Right? Now, okay, so that is known as delay. Now what is the meaning of packet loss? So you can see that in the router R1 all the packets are queued up. So when these packets are queued up, they are stored in the router's memory, and router is having very limited amount of memory. If the router's memory is full and even at that time router is receiving extra packet, in that case router has to drop that packet, and that is the reason why there is a packet loss, because of the limited memory of the router. Now let's see how many types of delays are there. In the computer network, there are mainly 4 types of delay: nodal processing delay, then there is a queuing delay, transmission delay, and the processing delay. Now let's see the first type of delay, that is the nodal processing delay. Right now you can see that the device A and B that is connected to router R1 and R1 is connected to R2. You can see that A is sending some packet to R1. When router receives the packet, it will analyze the packet. Now you can see that in this figure the R1 is connected to another router, that is R2. But in the real life, the router is having so many ports and one router is connected to multiple routers. So when router receives any packet, it will analyze the packet, and after analyzing, it will decide that which link would be the best choice in order to deliver the data to destination. So when router R1 receives the packet, it will analyze and it will select the one path from all the available path in order to deliver the packet. And time required to analyze the packet and decide that which part would be the best path, that time is known as nodal processing delay. During the processing of the packet, the router also checks whether the packet contains any error or not. The next delay, it is a queuing delay. You can see that in this figure there are 3 packets which are queued up. Now this packet has to wait until this packet gets transmitted, and the waiting time faced by this packet in order to wait until this packet gets transmitted, it is known as queuing delay. Okay, now let's see the next delay, which is the transmission delay. You can see that again we are seeing the same figure. The A and B are connected to R1 and R1 is connected to R2. Suppose the link between the R1 and R2, it is of 10 bits per second. The rate at which this link can transfer the data, it is a 10 bits per second, and the router is wanting to send the data of 20 bits. So the length of the packet is 20 bit and the rate of this link is 10 bits per second. Now what is the meaning of transmission delay? Transmission delay means the time required by the router R1 to put this packet onto the link. The time required by this router R1 to put this packet onto the link, it is known as transmission delay. And the equation of transmission delay is L by R. So what is the length of the packet? It is a 20 bits. And what is the rate? It is a 10 bits per second. So what will be the answer? 2 seconds. Okay. Now let's see the next delay, which is the propagation delay. Now when this packet has put onto the link, the time required for this packet to travel from source to destination, it is known as the propagation delay. The time required for the packet to propagate from the source to destination, it is known as propagation delay. And the equation for the propagation delay, it is a d by s, distance by speed. And the addition of this all delay, the propagation delay, transmission delay, queuing delay and processing delay, it is known as nodal delay. And this is it for this session. Thank you so much.